Hello and welcome back to module number 6. Today we're going to continue doing math in R part 2, but we will also start a new subject which is object-oriented programming and how it relates to R. And it is chapter 9 in our textbook, and we will discuss it because this is really important, and that will be in the end of the module and the beginning of next module. But today I want to start with the assignment, and some of you have encountered endless problems, and which is I really think it is good, even though you probably hate me right now for that. But the issue is that I want you to encounter mistakes that can happen, mistakes that you are not sure what you are doing, in order for you to get some confidence, in order for you to get some understanding what you are doing. And so this is part of the experience, this is part of how I like to teach it, and this is something that is really important because it will give you some common sense what to do and additional resource how to apply that. So in this case, what I did, I created two vectors. And again, I will talk about today about vectors, but I created two vectors in order for me to apply and then multiply the matrix by vector. So again, I took what I have covered in other modules and I apply that to the inverse matrix in order for me to get the result I want to, in order for me to apply. So this is the code. I will share it with you on Monday morning, but this is again the process that I think it's best. You might not agree with me, but based on my experience, I've been teaching this course quite a long time. You need to learn, you need to make mistake in order for you to learn, and that's how I see my role in that. Okay, back to where we started. We need to start talking about linear algebra, and it is the idea that compose the correlation, factor analysis, and structural equation modeling, but it also can be done in R. And understanding linear regression helps us to understand the issue of math in R. So linear algebra is a notation system that allowed us to put data at a higher level than rather than data points. And that's something that I want. And again, the assignment that I gave you was the point of it, and my mistake was that I made a mistake with a reference, but that's what I want you to do. And so the idea here is that matrix may be thought as a spreadsheet, but with its own algebra. And so R is quite explicit in that how it uses matrix, and so will I. So I want to make sure that you understand what it is. So example of simple algebra in R. So again, the use of matrix is the key component, but the matrix, I applied the vector in order for me to address it, and I'm using a new functions that you will encounter again and again throughout the semester. The percent sign, and again, this is something that I want you to become familiar with and how to apply that. Okay, back to the linear and what is it encoded. Solar is the idea of a single real number, and so the idea here is that we apply that in different metrics in different data set, and in vector, not a physical vector, but in idea of in the context of direction or multitude. So in this case, the solar can be displayed in different ways in vector. So this is an example of vector and solar and how it being applied to. So again, the vector here is the idea of x1, x2, xn, and the column of the numbers represent the solar in that sense. The matrix, as we learn And as we discussed in module 3 and 4, the matrix is a set of elements organized into rows and columns. It usually the idea that inform the same vector intensity at different times and different volumes at the same time. So a vector is just n multiplied by x matrix, and this is really important for us to remember because this is the outside of it, and this is how it probably will be able to catch it. So again, the basic matrix operation is just adding element or subtract element or multiply each row by each column in order for us to do that. So matrix times matrix, again, this is what we will do in order for us to do that, to find it. The matrix location size defined by the rows, which will be defined by x, and the columns is r multiplied by c, sorry. And so in this case, the d will be a representation of all the columns and the rows that we have in the set in order for us to capture that. If we will want to capture that differently, that will be the rectangular, which will be 3 multiplied by 2, or 3 multiplied by 3. Again, this is the dimensions and the sequence or the rectangular that we need to apply in order for us to make sense of what the data sets. So in matrix in R, we are talking about the type and the meaning of the X in that. So the reference in the matrix value is the X row and columns. So note that refer to all the row and columns, and the difference between the row and the columns in that sense. So in this case, what it represents, how it captured, and what you do with that, and how do you apply the matrix into it, can be based on what we have known or what we have captured. So what we have with regard to the matrix manipulation is when we're using the manipulation icon operates perfectly. However, multiplying two metrics, then as I said, you're going to see that quite often in our codes. We're using the percentage twice, and so we are using the multiplying the percentage as it is. So in this case, if we have to do that in R, we are using the container of 1 and 2 divided by 3 and 4, and B is 1 and minus 1 and 0 and k. And so the code in that sense, it will be applied to percentage multiplied percentage A multiplied by percentage B in order for us to get this type of matrix, in order for us to understand what we do. Another function in R is the solve function, which is the linear equation and finding the matrix inverse. And so in this case, we can apply the assignment that I gave you in module 5, and we can do the solve in order for us to do that. So in this case, A matrix and how to set it up, the solve will be the solve of the matrix, and the solve of A will solve the matrix inverse, which was the part of it. So what I did was I gave you a heads up into the idea of how to address the matrix, how to address the inverse matrix, and how to use a function that called solve in order for us to address that. The transposition of the matrix in that sense is that the columns goes to the row and the row to the columns, and by doing that we can manipulate or can calculate the overall addition. So the matrix calculation consists of the following, and in this case, this is how we will do it, and how we multiply and what we will do in order for us to do that. So simply put, it only can only perform A multiplied by B if the number of columns of A is equal to the number of columns in B, and you saw that quite clearly in R. R will not give you the ability to do something that is going beyond that, and by doing that, you will be able to catch mistakes beforehand. So again, I go over manipulation, I go over these slides, go over the manipulation, and in R, we are simply doing the percent multiplied by percent in order for us to highlight and try to do that. And by doing that, we can apply and describe. More linear functions in R, as outlined in the books. I use in the assignment, I use the T. It is the T matrix transform. And another good functions that the book highlight is the QR, or the Chomsky deposition, or the DET, deformation, and again, how to apply that and how to. We can also talk about identity matrix, which is a special matrix which plays a similar role as the number one in manipulation. So if the answer always A, why we use identity matrix? You cannot divide matrix, therefore to solve any or many problems, you need to use the inverse. So the identity is important in those type of calculation, and in this case, we will do that in the following manner if we will have pencil or pen to write on it. So identity matrix, this is how it will work. And in R, we have the idea that we can create a function that will allow us to do the identity function as a function that allows us to do the calculation. Dalek function produce the identity matrix in order for you to do that. Again, look at a textbook in page 198 and see how it use it in order for you to calculate the idea. More advanced techniques in matrix, I need to go over that just to make sure that we are coherent and understood the idea. Sweep function is just the apply the first two arguments of the array, and the margin in the example below, I use that in order for me to apply that. So I have the matrix, I have the number of rows I want to organize it, and I use the sweep function in order for me to add all those dimensions in order for me to display that. Vector components, again, this is something that is often used, and giving the ability to vector A and B to be summarized by the components and not only the bases. And the idea here is that giving the idea of it, we can apply, I played with it, sorry. We can use those dimensions in order for you to do that. And again, you can go back to R and ask him to do that if you're in trying to solve a problem on that. Again, the linear dependency and rank is also part of it. And again, this is the issue of how to present that, how to calculate that, and how to produce vector products and two vectors. What do you do with that, and how to apply that? The sector product of vector, how to apply that? Again, the textbook gives you a good representation. I cannot go over every single example that the book go, and because it will take my time and I will not be able to cover what I have planned already. But I think overall, the assignment number 5 and the assignment for this module will give you a better sense of the idea of the matrix and the idea of how to apply and how to apply the inverse. So again, set of operation, try to choose them, try to play with them to see what is the effect and how it apply in order for you to do that. An example of set operators. We have two containers, x and y. If we will do the union and we will set equal, we will go and the R will produce the result as true. If we want to invest the intercept between x and 2, and we will do the multiplication as we learn about the percentage multiply in percentage, again, the R will come up with the result and will be able to generate the idea. Simulation function in R is also part in our discussion, and simulation is one of the most common use in R. The function to do simulation is the R rainbow nom, which will generate two types of binomial and binomial random variable. And so to create 10,000 variables from a binomial distribution with 5 trials and success probability of 0, 1, true or false are treated as 1 and 0, allows us to estimate probability. So simulation, again, with a normal distribution, with exponential example to uninformed, and even Poisson allowed us to do that in R, and this is something that we want to explore. Again, I give you an example from the textbook and how to apply to it and what to do with it. Setting seeds for the same random stream in repeatable runs. So again, one of the things that we will see quite often, and a lot of example with a type of visualization, we use set seed, allowed us to recreate the same values when randomly sample or randomly generate values. So the idea here, I want to introduce to you the idea of random numbers. R has many functions to generate variable from a number to different distribution. As I said, R being on generate binomial variables. But we have, again, the ability to also generate the idea of it. How do we do the code with that? Is the idea of we establish a container and we establish the function inside in order for us to generate what it will see. See our textbook in page 204 for a full description of what he has done. So this is a summary of chapter number 8. We cover math function. We talked about function in statistical distribution. We talked about linear vector. We talked linear algebra. We talked about a vector as a cross product and built-in random variable generator. And we talked about linear. I know that I did not go on in depth about that. I did not describe all the titles, but because I wanted just to have you as a background, if you're going to create a package that will entail algebra, you will at least have some fundamental ideas how to address that. So I want to move to chapter 9, and the chapter 9 is talking about the object-oriented programming. And the idea here is that there's two things that is really important to highlight with regard to R and object-oriented programming. And the idea is that a language mechanism that allowed us to have a component R uses classes, and we will talk about those classes, class 3 and class 4, object 3 and object 4, and we will see what is it entail in order for us to understand why is it so important and what it allowed us to extend in order for us to do that. So what is the classes? you can set class attributes. One thing that it noticed that the class is a vector that allowed the object to inherit from multiple classes, and it allowed you to specify in order to inherit a more complex structure. You can save one classes to another, and you can implement one class to another too. So example, happy is a class, and we will apply class happy, and we can apply different statistical analysis into it. So appended class happy Monday, and it will be able to apply here, and I use the append is a new command here, which is the first argument is a vector, and the function adds to the arguments to end the vector. So in this case, this is how I overcome the idea of a vector and ended up the idea of it. The second command in class is use method, and one way to define method is a class use method command, and again in R it will look for a function whose prefix matches the current function, and it stretches for the surface in order for the vector of the class name. In other words, it will set up functions that can be defined, and the function that is being called to be determined by the class name of the first object in the argument. I know it's a little bit more complex, and I know that I'm reading it, but again, I want you to go over that, and I will show you an example, because this is the best way to do that. Happy, and I will define it as a list, and the first is 1, the second is 2, and the third is 3. So the class happy, and I will use the function append, and it will end up the idea of a vector here, and then when I will say happy, or will come back and say $sign first, which means 1. And if I will say $sign second, he will say 2. And so again, I'm going to generate the first function, and I will use methods to get the first and get first Monday function in order for me to address, and this is part of the use of method function in order for me to do that. I know that I covered a lot, and I still want you to read it because it's overlap, and sometimes I repeat the textbook, but it will give you more visual representation and give you more context in that. So the first time in the next class, we are going to discuss the very important subject of S3 class, which is a really important. There's 2 classes, S3 and S4, and S3 is considered to be the oldest type of class, and we will see how can we apply to it and how to do that. So until next time, I hope you enjoy that. I hope you will learn something new, and until next time, have fun.